Okay, so this is the Types of Chemical Reactions Lab video. My name is Mr. Rasmussen, if you don't have me as a teacher. And I'm going to be going through the video, following the procedures in the document. So please, as we are going through this, have your Google Doc open of the Types of Reactions Lab. The observations are to be taken at the top of the second page. There's a data table there where you can just write the observations in. So as you're doing this lab, the video, the only thing you really need to be doing and paying attention to are your observations. The other parts of the table can be filled in by reading the document carefully to figure out what all of the chemicals are. But as far as this video is concerned, really the only thing you need to be doing is writing down observations for each reaction. Okay, so reaction one, I already have the Bunsen burner lit, and it says I'm supposed to hold a beaker above the flame upside down for 5 to 10 seconds, taking observations of what I see. So the thing says, the procedure says that the chemicals that are being used here, the natural gas is methane, which has the chemical formula CH4. It is now currently, hopefully you can see the blue flame there, reacting with oxygen in the air. So I will put this beaker over it. These are beaker tongs. They have the rubber coating on the end to stop the beaker from slipping through. They add a little bit of friction. I'm going to put that over the flame and then bring it close to the camera here, and hopefully you'll see what you're supposed to see. I know that with the video it's not maybe going to be quite as obvious, but here I go with putting it over the flame. Notice something there. You can see how it's changed. Happened again. You can kind of see it a little bit, maybe. And then when this gets too hot, it doesn't do that anymore. Try it one more time with a different beaker. This is a different beaker that's cold still. Well, not cold, but room temperature. Put it over there. That one maybe was a little bit more obvious. Hope so. Okay, that's all of reaction one. I'm going to keep the Bunsen burner lit because I do need fire later for the gas test. Okay, reaction two is the reaction of magnesium metal with hydrochloric acid. These will be taking place in the test tubes here. We'll just go from left to right. So test tube, it's clean, there's nothing in it, relatively clean at least. Magnesium metal comes in a variety of forms. The form I'll be using today is a magnesium strip. It's just a thin piece of magnesium. It's silver, it's shiny, just like you would expect from any metal. So I'll crumple that into a ball, throw it in the test tube here. Glad it's at the bottom. There is something called the flame test that you can use to test the identity of certain gases if they're produced. So some of these reactions are going to bubble. And what I'm going to do is I'm going to take a wooden splint, it's just a coffee stirrer, I'm going to set it on fire in the Bunsen burner. I'm going to blow the fire out so that it's still glowing red hot. And I'm going to put that in the test tube because the gases that are formed should stay, kind of in the test tube. There's three gases that we're testing for: hydrogen gas, oxygen gas, and carbon dioxide. Hydrogen gas is very flammable, so when the red hot coffee stirrer goes into the test tube, it should ignite the hydrogen gas, which would make a popping noise because of the shape of the test tube, the opening there. If it's oxygen, fire needs oxygen to burn, so the red hot stir stick should glow more. But oxygen itself is inflammable. It just allows other things to burn. So it's not actually going to set on fire. It's not going to ignite as if it were hydrogen gas. Carbon dioxide is an inert gas, which means it doesn't really react. So if that's the case, it should put out all of the smoldering embers on the stir stick, and then it should just smoke a whole bunch and not be glowing red anymore. It'll basically put it out. So it's either going to explode, it'll burn more, or it'll go out completely, and that will tell us which gas it is. So I have the magnesium here in the tube. I think that's in the camera. It's hard to see down there. I'm going to add the hydrochloric acid to it. HCl 1.0 molar. I am wearing safety goggles, so don't worry about me. And then as you can see, I hope, there's a whole bunch of bubbles and fizzing going on. I'll let that do that for a while. I'm going to set my stirrer on fire. Still bubbling. And then put this out, see what happens. I think you saw and heard that one, so that was definitely an ignition. There is some gas that was lit on fire, so it is most likely hydrogen gas. Okay, that is reaction 2. Reaction 3, we need to combine zinc with copper 2 chloride, it says. I will use a new test tube. There's nothing in that one. The zinc metal is in this plastic container. It is not as silver or shiny as the magnesium because it reacts readily with oxygen in the air. So it kind of has this white coating on it. But if you were to scrape that white coating away, which I might be able to do with my fingernail, it's not quite as shiny as you would expect a metal to be. It's a little bit dull. Zinc is an interesting metal. So I'm going to put a couple pieces in here just to make sure we see what we're supposed to see. With a couple pieces at the bottom of that test tube. If I bring it in closer than that, it gets out of focus, so that's about my limit. Okay, and then the copper 2 chloride is this blue liquid. I'll add that in there, and we will see what, if anything, happens. Ta-da. Okay, so I have put the copper chloride in with the zinc. Let me try to refocus my camera. There, it's better. So little tiny baby bubbles. There, that's a good one. So there's definitely a reaction happening. This reaction takes a while to go to completion. So we might need to take a break. The camera does not want to stay focused. There it goes. Keeps wanting to focus on the background. Okay, we should probably see if this gas is something fun. Or what it is. It's not really doing anything. So hopefully you can see a change now. So remember, the copper chloride was this color before the reaction, and this is what's happened to it. And that's about it for that one. Okay, reaction number 4 is the reaction between calcium carbonate and hydrochloric acid. Calcium carbonate is better known as a few other things, some of which are chalk or coral, or in this case I have marble chips. But they're all made out of basically the same thing, calcium carbonate. And to that I'm supposed to add hydrochloric acid. I have some slightly stronger hydrochloric acid here because these marble chips can sometimes take a bit to react. So this is reaction number 4, calcium carbonate and hydrochloric acid. We will see what happens here. then set my stick on fire. I'm going to let this gas build up for a minute. I'm going to throw this in there. We'll see what happens. Ooh, that went out immediately. So it should tell you which gas it is if it went out immediately. Remember, hydrogen explodes. Oxygen makes reactions happen faster, specifically combustion reactions. And then carbon dioxide would put a combustion reaction out. Basically snuff it out. Okay, and the reaction 5 is the decomposition of hydrogen peroxide. So I need to put 20 drops of hydrogen peroxide in my next test tube first. This is just over-the-counter hydrogen peroxide. 1, 2. That's about 20, we'll say. And then I need the ittiest bittiest baby bit of manganese dioxide, which is how it's commonly known. Its chemical name is manganese 4 oxide. So I'm going to take just a little baby bit of this stuff. It's a fine black powder. This is not involved in the chemical reaction. It is a catalyst. So hydrogen peroxide does decompose all by itself without any other chemicals reacting with it. Please remember the definition of a decomposition reaction. You only have one reactant and it splits apart. So there is no other chemical needed for this reaction to happen. This is a catalyst, and what the catalyst does is it allows the reaction to happen faster and at lower temperatures. So the catalyst, the black powder is at the end there. Put a little baby bit in there. And hopefully you can see what's going on. Again, it's hard to see with the camera focusing a whole bunch, but there it goes. There are some bubbles being formed. I'm going to put my thumb over the top to try to capture the gas. I'm going to add a little bit more hydrogen peroxide to this because I do want to make sure that I'm getting enough gas here in order for our flame test to be able to tell us anything about the identity of this gas. I'm going to grab a new splint because I used the last one to scoop a chemical. So ooh, and then that glue a little bit brighter, I could tell. So as I put that in there, the orange turned to white. The orange, glowing orange color of the splint turned to white, and I could tell that it was burning a little bit faster and hotter, but definitely not an explosion. So that's it. Hopefully you got some great observations, and then you can go ahead and fill the rest of the table in by reading the procedure. The procedure does tell you some chemicals that were involved in the reaction, and then the observations should be able to tell you some of the chemicals that were produced.